Welcome to the channel, I'm Lauro Müller and I make videos about programming. Big day because today we start diving into JavaScript. We are going to go through an overview of the JavaScript syntax, so the main constructs that the language uses, and we will discuss the main use cases for each of them. Of course, this is a summary, it's an overview, it's a bird's eye overview that is going to give you a base understanding of how the language looks like. But there is still a lot more to discuss and we'll go into much more details in later videos of the series. Pretty cool, cannot wait, so let's get started. Here are the topics we'll cover in this JavaScript syntax overview. We will talk about comments, console.log, numbers and strings, variables, operators, functions, objects, arrays, classes, control flow, exceptions, and semicolons. By the way, I think I forgot to mention this in the setup part. If you don't have an IDE installed, I would recommend you can download VS Code. It's a free one. WebStorm, the one I use here, it's not free. It had some benefits. There are different opinions, some people prefer VS Code, they say it's faster. Some people prefer WebStorm, they say it has better plugins, it's more stable. In any case, for all our purposes here, any of these two is completely fine. The one that is available in the online environment is a flavor of VS Code. So if you install that one, it's also okay, it's no problem. Maybe a couple of commands are gonna change, like the IDE commands, not JavaScript commands. JavaScript is the same in both, but the IDE commands, a few may change. Here, I don't think you will feel any difference between using WebStorm or VS Code or any other free IDE such as Atom. So back at the IDE here, let's create one file. We'll start discussing comments. So new file, comments.js. And there are three types of comments that I want to discuss with you. The first one is a single line comment, and it is represented by this double /, right? I am a single line comment. Very exciting, I'm sorry, but at the beginning it's always like this when we have to go through the very basics. Maybe it's a little bit boring, but I really want you to have a solid understanding of how the language looks like. So the multi-line comment, of course, if we want to write multiple lines, here I can say I can be written in multiple lines, right? If I were to come here and start writing something here, this would be the second line, and you see that I'm going to start having quite a few errors. So this double / is one line, and the single / with this star here, I don't know how to call it, star asterisk, anyway, the construct like this is going to allow you to have multiple lines. Now there is a third type of comment, which is not really a JavaScript comment, it's more of a convention. If you prepend, or if you start any comment with the to do keyword, in most IDEs this is going to be highlighted, right? So to do, implement something different in the future, for example, or refactor, let's call it like this, do a bit of refactoring here. And of course you wouldn't write such a general comment, but that's just an example. You see that this is highlighted differently, and there are utilities within the IDE that help you to quickly find such comments, okay? This is the third one that I wanted to show you. There is a fourth one, which is a JS doc, which is something like this. We are gonna enter into more details of this in the advanced course. I'm not going to discuss the JS docs too much now. I'm not going to discuss them at all because I think I rarely ever see them. They are very good for documentation, but for our purposes here, for the introduction to JavaScript, I'm not going to cover them to a great extent. Actually, I'm not going to use comments at all. Maybe just if I want to show you how a certain output looks like, or what is expected from the console, then it's okay to use a comment, but it's just going to be for, let's say, quote unquote, teaching purposes. In actual code, you would try to write as much code, as much self-documenting code as possible. We want to avoid comments because, well, they don't do anything, they just explain some stuff. And if your code is so hard that it needs a lot of comments to be explained, then maybe you need to rethink your code and not write a lot of comments, right? So code should be easy to understand. It should read naturally to us humans instead of being such a complex logic or complex thinking that we cannot follow, or we need to spend hours to understand what a single function does. So that's a personal opinion of mine. You will find different opinions somewhere else. For me, I find that writing clear code and writing self-documenting code, meaning naming the variables meaningfully, naming the functions meaningfully, having small functions, having a clear control flow, for me, this is much more helpful than adding a bunch of comments. Sometimes, nonetheless, you may want to use them for very specific reasons, and now you know how they look like in JavaScript. The next one is the console. So let's create here a new file, console.js. And this is the first file we're going to execute in the node or in the terminal, right? So here, the console statement, we have console.log, and we can say, again, we already did that, hello world. Once I save this, we can then run here in the console. We'll say node console.js, and that's going to output console.log. We can also perform a couple of operations here. So console.log 1 plus 2. This should output 3, right? So if I rerun this, it's going to be 3. And I can also do some comparisons, whatever. This would be an operator, 1 equals 1. If I run this, I get a true. And then if I want to say console.log, I can also actually, there are other constructs. They don't need to be the log. You have console.info. You have console.warn, you have console.error, for example. I don't know, let's see what happens if I console.error 2, it just outputs to the console, right? So the difference here is that the console.error is going to output to the std error stream instead of the std out, right? So this one is going to be std out, and this one also going to be std out, and this one as well. But the error is going to output to a different stream. Now, this is for us here really not necessary to know. We will use console.log most of the time, if ever, right? So we would avoid console.log in actual code, but here, since this is an introduction, we will use console.log a lot because we want to visualize the result of our operations. Let's mark the comments and the console.log statement as completed. Let's move on to discussing numbers and strings. So here in the IDE, I'm going to create a new file, numbersstrings.js, and I will use the console.log just to avoid these annoying warnings from the IDE. So if I write, for example, 1, I'm going to start getting these squiggly lines here at the bottom. I don't want them, so I'll just use console.log. And numbers really look like numbers, right? So 1 minus 1 is also fine. A decimal is also, or floating point number is also fine. For JavaScript, both integers and floating point numbers are the same basic type number. The only distinct number that we have is if we write with an n here after this, and this stands for the big int type, which can grow arbitrarily large in size, right? So there are some limitations about the maximum value that we can store in a number in JavaScript. If we want to store more than that, we can use the big int type. Now we also have a couple of constants. If we want, we can say the math library is a built-in library. Math.py, for example, is a constant. So this is how the numbers look like. We can also divide, right? So 1 divided by 3, for example. And once I save this, I'll come back to the console. Let me clear everything, and I'll say node numbers strings, right? And this is going to be the output on the screen. No big surprises here, very easy to understand. And about strings, let me add then here a couple of comments. And as you can see, these are just helpers so that we understand which parts of the file refer to which contents. Now there are 3 ways of representing strings on the screen, on the files. The first one is to use single quotes, and that is the typical hello world. We can also use double quotes instead of single quotes, like this. Oops. And this is also fine. And the third way is we can use backticks, like so, backticks. Now, what is the difference between these 2 or these 3? Between single quotes and double quotes, almost nothing. Yeah, I'm not even going to discuss that because I don't know it myself, right? I normally use single quotes, and that is out of habit. And also there are some automated code formatters like Prettier, and I always set the option to single quote to be true, and I use that. I can use double quotes sometimes, but I don't really make any distinction between these two. The backticks, however, they are very nice because they allow us to interpolate variables within the strings. What do I mean by that? Well, let's say that I have a number, not a number, but a name, and I'm gonna call that name to be very creative, my own name, right? And now I want to print this name on the screen. If I were to use double quotes or single quotes, I would do something like this: console.log hello, and then a space plus name, right? And that's fine. I'll save this and I will execute on the screen here, and you will see hello Lauro. No big surprises. That's the expected behavior. I can use the plus. That's an operator. We will explore this in a few seconds. But I can also use the backticks, and the backticks, they allow us to do quite a nice way of doing interpolation, right? So interpolation means add the value of a certain variable in the string without really explicitly saying this plus here. Just interpolate the value of a variable in the whole string. And as you can imagine, this is really helpful because it allows us to really write the string as we want and then substitute parts of it for the or with the values of variables. If I save this and I run again, I will have hello Lauro. Now this is just one example, right? So it's quite similar, but let's say that I want to write a couple of stuff. So console.log hello, and then this is my first name. So let's call it like this: first name. Then I have my last name, and that's going to be Müller. And then I have my age, right? And I know we didn't discuss variables yet, but I think you can understand what I'm doing here, right? So all I'm doing is just naming these values for later usage, right? So we have the first name here, we have the, let's say, first name here as well. And now if I want to write, or if I want to print a bit more complex output, if I want to, let's say, write something like this: hello Lauro, or let's say dash Mr. Müller, you are 27 years old, something like this, right? So if I want to output this in the console by using these double quotes or single quotes, I would have something like this. So let's use now, for the sake of variety, let's use single quotes. I would have hello, and then here again, plus first name, plus then I need to make sure that I add the space, that I add the space, the forward dash, and then that I add Mr. dot, and again a space, and then the last name, like so, and then I add the comma. So where is it? Here, comma, you are, another space, age, plus, and then again, years old. Right, so it's quite a lengthy and error-prone syntax, because if we forget a space here, for example, then we're going to print a different string, right? So if I save this and I run, then I should get the expected output. But there is a faster way, and it is to use backticks. If I use backticks, I can simply say hello. Maybe I actually even copy this string here, and then let's just substitute the values with the variables. First name, Mr. like so, last name, you are, age, years old, right? So much cleaner, much easier to understand what it is doing. So I really like backticks whenever we need to interpolate the values of variables with other parts of a string. We're done discussing the syntax for numbers and strings. Let's now discuss for variables. So let's create a new file here, and we already started discussing the syntax for variables. There are two ways of declaring variables in JavaScript. The first one is to use const, and const is going to create an immutable binding between the name of the variable and its value. Now, what does immutable binding mean? I know that the name is complex, but the idea here is that I cannot assign any other value to x if I declare x using the keyword const. So if I were to do it something like this, x equals 15, it's going to complain. It's going to say, you cannot really do that because x is declared as a const. If I want to be able to reassign x, then I have to use let, right? If I use let, then x has a mutable binding and I can assign a new value to the variable x. Now let's go back to using const because I just want to show you one little thing here. Now, and that's why I use the term immutable binding and not immutable value, because if I declare x to be an object, like so, I can still add properties. X.firstName, for example, like this, I can still do that. It's no problem because x now is referring to the memory address, to the reference of this object. So when I am adding new properties, I'm not really mutating the binding of the variable x. I'm not really mutating the reference. I'm mutating the contents of the object, but the reference stays the same. Now, of course, I cannot do it like this. I cannot assign x to a new object. So a very quick way of thinking about it is, or very shortcut, right, is to think it like so. If I declare with const, I cannot reassign the value. If I declare with let, I can reassign the value. Then I can really here do x is equal to another object, is no problem. Okay, these are the two ways that we can declare variables. So let's say const x equals 10, let y, and then we'll say y equals 5. And here is another thing that I wanted to discuss, is that here I am declaring a variable, but I am not initializing it. Let's see what is the value for y. And as you may expect, this is not initialized, which means it is undefined, right? So JavaScript is going to print that the value of y is undefined. And once I assign a value to it and I console.log it, then it's going to console 10, or actually in this case 5, right? Not the 10 from x, but 5 here from y. Now I cannot do this with const. I cannot do it like this, const z, and leave it uninitialized, because I'm using the keyword const, which means I have to create immediately a binding or an immutable binding for this variable, right? If I don't initialize it, then later on, if I try to assign it to something else, I would be violating this rule. So I will save this. Let's try to run this in the console, clear this whole thing up, node variables.js, and as expected, the first value of y is undefined, and then the second value of y is equal to 5. Variables, check. Let's go through the operators. Now, operators, there are quite a few things, or quite a few different types of operators. I'm going to create operators.js. Maybe I can close the other files or the other tabs here. And we have a couple of types of operators. We will have arithmetic operators, we have Boolean operators, and we have comparison operators, right? So what does each of these operators do? So for the arithmetic operators, that's quite straightforward. We are going to perform, guess what? Arithmetic operations, right? So plus, minus, oops, sorry, maybe it's easier if I just declare a couple of variables here. Let y, let's do it like this. Let x, let y, let z. If you want, you can also declare the whole thing in one line, let x, y, z. That's also okay, right? It's no problem. JavaScript allows you to do so, but personally, I prefer to declare them on the top of each other so that I know how many variables are actually being declared and will be used later on in the code. So here we will say x is equal to 10, y is equal to minus 5, and then we'll do a couple of operations with z, right? So z is equal to x plus y. Here, z is equal to x minus y, for example. Or even better, let's get rid of the z here, because this is gonna get confusing, I think, because we are always reassigning. Let's just do a bunch of console.logs. That's easier, right? It's easier to understand. Erase this whole thing here, and a bunch of console.logs, and then we have plus, minus, we can divide, we can multiply, we can do the module, And maybe here for the module, this is going to be a little bit weird with 10 and minus 5. So let's maybe change this to 3, for example. And the module operator is a little bit different. I will explain what it does when we talk in details about operators. No, changed my mind. I'm going to explain what it does now. So when we divide 10 by 3, right? So if we divide 10 by 3, we get an integer result and a decimal result, right? So if we were to make an integer division, 10 divided by 3, 10, so maybe I actually put this here next to the module operator. 10 divided by 3, if it is an integer division, this is going to be 3, and we have a rest of 1, right? Rest of 1 is 1 hanging around that cannot be divided by 3, and this is the result of the module operator. So the module operator performs an integer division between the two operands x and y, and if there is any rest, or actually it always returns the rest, so it can be 1, it can also be 0. So if I were to do it like so, console.log, and here let's just be precise, console.log x modules 2, then this is going to output 2, right? Output, sorry, not 2, 0 on the screen. Let's save this, let's run this in the terminal. Clear everything, not npm but node, and this is going to be operators, right? And then you'll see that that's what I mean. So 10 plus 3 is 13, 10 minus 3 is 7, 10 divided by 3 is 3.3333 forever, right? This is just doing some approximation here, but it should not continue forever. And then we have 10 times 3, that's 30, and we have then 10 module 3, that's the rest of 1 that is being returned here, and we have 10 module 2, that is the rest of 0. We can also do, for example, power operations, x power x to the power of y. Once I save this, let's run the whole thing again, and you see we have 1,000, right? We also have an built-in math library that we can use to do quite a few mathematical operations here. You can see many options, many constants. So if you want to play around with it, feel free to do so. These are the main arithmetic operators. We now move to Boolean operators, and Boolean operators, there are a couple of them. I just want to show you the main, how do I say it? So the most common ones and how they are used. So let's declare a couple more, W and T here. And we don't even need this. We can just go with the Boolean values themselves, true and true. Right, and then the AND operator is going to return true only if both are true. This is just a warning from the IDE saying that the whole thing can be simplified, but here I just want to show you how to use it. We have true and false. This is going to output false. This is true. We also have the OR Boolean operator. The OR Boolean operator is going to return false only if both are false, so this is going to be true. And if we have if we have false or false, this is going to be false, right? So these are the Boolean operators. There are a couple more, but the ones that we will use the most are these ones. And of course here you would have a couple of more complex conditions. For example, you could think x less than 15 and y greater than 1, right? So this is going to output true if you have something like x less than 15 and y less than 1, then this is going to output false. I'm going to save this. Let's run the whole thing, and then you can see these are the outputs that we have here: true, false, right? So we would have a couple of checks, and then we can use Boolean operators to make sure that we get the desired behavior or the desired combination between these checks in our control flow statements. And we also have comparison operators, and I already started using the comparison operators here. So the comparison operators, they return Booleans, right? So if I say x is less than 15, that's true. I can also say, let's change 15 to 10, for example, and this is false, right? So x is not smaller than 10, x is smaller or equal to 10. This is true. And I also have other types of operators, so greater, equal to, that's also fine. We also have the triple equal and the different, like so. So maybe I just write the whole thing here, right? This is going to be the different one, and this is false. Now the comparison operators, we also have the equal, but this is discouraged. You see that the IDE already starts complaining, and this is discouraged because of type coercion, right? So, or not type, yeah, type coercion. That's exactly the case. So if I write it something like this, 10 double equal 10, this will output true, right? Let's save this and let's run. And you see here it's this true here, because it's transforming this string into a number before running the operator. If I use the triple equal here and I save this, then and I rerun the code, then you see that this is false because the string is not equal to a number, right? So personal tip, never ever use the equal. I mean, people say never use never, right? Never say that you will never use an operator, but I can tell you, never use double equal. Use triple equal always. There is no case where type coercion is going to bring you a strong benefit, right? If you need to be changing the types of values and the types of variables during your code, then maybe there is something that can be improved in your code. Let's switch this back to X, like so, and that is true. That's false. I'll save this. If I rerun the whole thing, then I should get the expected results, right? False, true, true, false. If I read here the 4 ones at the bottom, that's exactly what we expect. Operators, check. Now let's discuss functions. So how do functions look like? I'll create a new file here, functions.js. And there are two ways of declaring functions. The first one is to use the keyword function and then give it a name. So let's say add, right? And then it's going to receive 2 parameters. And this function is going to return a plus b. Quite simple, right? So if I were to say const x equals 10, const y equals 3 or 2, well, let's say quite original, and we'll say console.log add x and y. This is going to output the 12 on the screen, right? So it's going to output 12, not the 12, but 12 on the screen. Let's clear the whole thing and let's run node. Oops, not noped. Here, node. Oops, node, like so. Yeah, functions.js, this outputs 12 on the screen. Another way that we can declare a function is to use what is called an arrow function. Now, the arrow function is actually assigned to a variable, and we are going to say subtract, and this is an arrow function, like so. And an arrow function does pretty much the same. I mean, it receives some parameters, does some calculation. So let's do it a and b here. Return a minus b, and that's going to be exactly the same to call it, right? So subtract and x and y, this should output 8, if I'm correct. Exactly, this should output 8 on the screen. Now there are some differences here when it comes to using these two functions, but we will discuss this at a later point. And this is just an overview of how the function, or how functions look like in JavaScript. You can encounter both these shapes with the function keyword and with an arrow function. And you can also have something that's called an anonymous function, which is a function like this, which is assigned to a variable, but it has no name, right? You see here that it has no name, but still it can receive 2 parameters and it will return a divided by b. So let's now, oops, let's just maybe move this a little bit up here, and this one we'll call divide, and this is going to output 5 on the screen, right? So these are 3 different ways that we can create functions in JavaScript. When to use which and what are the differences between them, we will explore at a later point in time. Functions, check. Now let's move to objects. New file, objects.js, and an object in JavaScript. So let's assign this to a variable already. I already mentioned it to you. It's simply curly brackets, like so. Right, so this is an object. Then I can say first name. First name is going to be Lauro. This is what is called the property of the object. So let's declare another one. Last name Müller. This is another property of the object, but we can also have methods, and methods are nothing more than functions. So get full name, and then I can access the other properties or other methods of this object by using the keyword this, right? So here I can say return and then backticks for you, because that's how I like to interpolate values. This dot first name space, and then again interpolation this dot last name, right? So if I were to come here and say console.log obj.get full name, this is going to output Laudermüller on the screen. Let's clear the whole thing, node objects.js, there you go, Laudermüller. Now, of course, you can also add properties if you want to. So we can also add a new method, get last name, for example. And this is going to be a function, like so, an anonymous function. It has no parameters and it will just return this dot last name, right? So if I save this and I write console.log obj.get last name, save this and run the whole thing again, I get Müller on the screen. Now you see one limitation of the arrow functions. If I were to say get first name, for example, and I want to create a new method here and I use an arrow function and then I try to say something like this dot first name, let's see what's going to happen. I save this. Oops, sorry, forgot to write the console.log. It's going to be dot get first name. And I'll save this on the screen and I'll run, and you see that I get an undefined. I don't get Lauro here, right? I don't get Lauro here. I get an undefined. And this is because this keyword has a different meaning within an arrow function. And that's one of the differences that we'll explore later on. So for objects, if you want to add methods, I would recommend stick to the function keyword so that you have access to this keyword, which represents the whole object. Now, of course, there is much more to objects and we will discuss them in much more detail later on. But for now, at least you know how they look like, right? Of course, I can also change things here. Let's say that so let's erase this because this doesn't do anything. And I'm going to say obj.first name is equal to John, right? John Müller. That's a nice name. And then I will console.log here again, obj.get full name. Once I do that and run the code, then you see, yeah, John Müller as expected. Objects done. Let's explore how arrays look like. New file for you, arrays.js. And arrays are right? So let's use R, and they're just a set of square brackets. And I can, once I declare an array, I can initialize it with a couple of values. They don't need to be of the same type. I can say 1, 2, a, and then an object with a first name of Lauro, for example. And I have a couple of methods that I can call from the array. So if I were to just console.log r, right? I'll save this. Let's clear here, node arrays.js, and then we get the array on the screen. I can also access an individual element of the array by using the index, and the index here, it really starts at 0, right? So I'm going to write the index here. That's going to be index 0, that's going to be index 1, this is going to be index 2, and this is going to be index 3. So if I were to access the fourth element, I would use the index 3. Once I run this, I get the object here. And if I were to try to access an index that is not defined, for example, array 10, and I save this, I get undefined, right? So you may also get the reference error if maybe you are at a different environment. It may also be the case that this is going to throw you a reference error, right? If I were to maybe, let's say, try to access this, let's see what's going to do. And there you have your not reference, but type error, right? So it's going to, because the value is undefined, you of course cannot access the first name of an undefined value. So the program is going to throw you an error. Okay. Another thing that you can do with arrays, you can add elements, you can push elements to the array. So let's say, let's push, that's the fifth element. So maybe we push 10, just not to make things confusing. And if I were to console.log the array again, then I will have the fifth element also in my array, right? So the number 10 here. I have a couple of methods as well. I have not methods, but properties, array.length. And this is going to give 5 or whatever length you have in your array. That's basics of arrays. You know how they look like. Of course, there are many different cool things that we can do with arrays. I'm going to mark this as checked. We'll go back to arrays later on. Let's discuss classes now. Classes are something that, there are some different opinions on the internet. Some people like it, some people don't. I really like them, and when we use TypeScript, it becomes super cool to work with classes, so we are gonna work with classes as much as possible in later points in this course. Maybe this course is not going to be the best environment to use classes because it's an introduction course, and well, maybe the case that we're not going to use that much classes here, but when we move to actually applied knowledge, we're going to use classes a lot. So how do classes look like? Well, a class is it basically defines a blueprint for a certain object. So let's go back here to my objects file. I'm going to copy this whole thing here, and I'm going to print this. I'm going to paste this here, right? So this is not a class. This is a simple object, but I can identify that there are a couple of properties that I would like to have. So let's say this is a person, right? And then here I would like to define a blueprint for a person, and the blueprint is going to be called person, or I can call it whatever I want. Person blueprint or something is fine, but the convention is normally to use a capital letter, so uppercase letter to begin, and just a noun to describe which object, which entity you are describing in the class, right? So once you define the class, you have the constructor, and the constructor is going to be used to create objects that conform to this blueprint. So here, how do we create a new person? Well, let's leave it like this for the moment. We will see now that we can create a new simple person, right? A simple person here by simply calling new person like so. And then we have a simple person here. Now, simple person is a object of type or of class. Person is an instance of this person class, right? So now, of course, I want to store the first name and I want to store the last name, so I can pass these things as parameters to my constructor. Here, let's pass first name and last name, like so. And then I will simply say this dot first name is equal to first name, and this dot last name is equal to last name, right? And then I can also define a method to get my full name. Get full name is going to return, and then I'm just copy and paste here. I don't need to type the whole thing again. Return this dot first name and this dot last name. And now once I create a new person, then I can pass the first name and the last name here. So now instead of declaring the whole structure of the object here, I will say new person. And this actually, let me just leave this on the screen, and this will also be here on the screen because I want to do a bit of examples afterwards. Let's say const Lauro. Lauro is a new person with a first name of Lauro and a last name of Müller, right? Now, okay, this Lauro here does exactly the same as this person, but as you can see, it's much cleaner. It's much nicer to define an object by creating a new instance of the class. And if I want to create another object, I don't really need to worry about the internal representation of things. I can just create, let's say, John here, and then John is going to be another person, like so, John Müller, right? Or John Schmidt. I don't know how to write it, but Schmidt. I don't know. Let's leave the Müller here. Yeah. In any case, here, if I were to define a new person, so if I were to, let's say, Lauro 2 or Lauro old, if I were to create a new John person, I would have to have here John old, and then I would change the name to John, right? So it's, I think, a cleaner syntax when we work with classes. And yeah, that is one thing we'll also explore in more details. In vanilla JavaScript, in pure JavaScript, classes don't offer that much advantage, but when we integrate TypeScript, and that's what we will do in the next introduction course, and from then on we will use only TypeScript. We're not going to use JavaScript. In very rare cases for configuration files, maybe we still use JavaScript, but vast majority is going to be TypeScript. Once we integrate TypeScript, then working with classes becomes extremely intuitive, and it allows us to discover and to implement a lot of very powerful design patterns in our TypeScript code. So that's why I'm giving you an overview of classes now. We'll also discuss classes later on. This is just how they look like. They have a method that is going to be called every time we create a new instance of that class. This method can receive variables or parameters, which can then be assigned to fields within the class, and the class can also have methods, right? So you can see that this pretty much maps to the object here. Now, can I add new properties to the class? Of course. Lauro.age is equal to 27 is no problem. In TypeScript, in JavaScript, this is no problem. You can add whatever you want. You can even change here the first name, Lauro.firstname, to be equal to 27. JavaScript is not going to complain, but of course this is bad, right? So we would like to have a well-defined blueprint for our class, and this is where TypeScript comes into play. Okay, enough talking about how to use TypeScript in a JavaScript introduction course. I just wanted to show you how classes look like. So let's mark classes here as completed, and let's discuss control flow. New file here, control flow, right? Control-flow.js, and there are two types of control flow. We have conditional execution of code, and we have loops. Right, so we're gonna say, let's say const x is equal to 10, and we'll say if x is less than 10, we are gonna print console, right? Console.log, very little, maybe, yeah, very little, or only a few units left. Otherwise, else here we'll say console.log, enough units left, right? So we can have a if condition is true, we will print this code of this code block here. Otherwise, if this evaluates to false, we're going to execute the else statement. We can also chain a couple of these together. So if x is less than 10, only a few units left. If else, if x is less than 20, enough units less, else not enough units less, enough units left, and else if x is more than 20, then this will be too many units, right? Let's say this is in an inventory application or something. If then I come back to the console, I can execute this with node control flow, and then you see it's gonna print, of course, twice enough units less left because x equals to 10. But if I were to switch this to 30, this is going to print enough units left from the first condition, but it's gonna print too many units from the second condition, right? So enough units left and too many units. This is the conditional execution. Another conditional execution that we can have is to have a switch statement, and the switch statement is going to receive a certain value here. We're going to pass x, and then it's going to have a couple of cases here that we will execute. Case, let's say 10, right? So if x is equal to 10, we will console.log x is 10, like so. And then we're gonna break, and we use this break here not to continue the execution, but we can also have other cases, right? So case 20, and then we'll say console.log x is 20, and we can also use break here, and we'll say case 30, console.log x is 30, and we can again break, and then here we can have a default, which is going to be executed in case none of these conditions match. So here we'll just say console.log x is not 10, neither 20, nor actually that's bad English, neither 10, 20, nor 30. Okay, I think that's better, right? So if we were to save this now, let's execute the whole thing. This is going to print x is 30 as the last line. But if we were to change to 35, for example, we'll save this, and then it's going to print x is neither 10, 20, nor 30. Okay. Now loops, there are a couple of loops that a couple of types of loops that we can have. The most traditional one is to have a for loop, right? So for let some counter here start at 0 while this counter is less than a certain threshold, let's say 10, do something, and then a post execution we are going to increment the counter, right? So let's say console.log I. Just like this, we're going to print the numbers from 0 till 9. Once I save this and I run the program, you'll see from 0 till 9, right? We can also have a while loop. So while, and then here we need to start the counter outside. Let counter equals 0, while counter less than 10. Let's not, first things first, let's increment this, and then we'll say console.log counter. And let's run the code. And as you can see, it also prints from 0 till 9, right? So these are two types of loops that we have. Now there is a third loop, which is quite useful. And this loop is to iterate over the values of an array, or over the values of an iterable more generally. So let's start with an array here. R is equal to, we're going to say 1a me minus 2, right? And now if we were to print all the values here of this array, we would have to know the length of the array. So if we were to use a for loop, we could do something like this. For let I less than the array.length, I plus plus console.log I. And let me just comment this out because this will output too much on the screen. Once I run the code here, we will have 0, 1, 2, 3. Sorry, that shouldn't be, that should be the array element at index I. And then we get 1a, me, and minus 2. Another way of writing this loop is to use a for off loop, which is going to use the following syntax: for const element of R console.log element. Right, this is cleaner. I think it's cleaner, and we don't have this whole conditions here. We don't need to worry about making sure that we are within the array. That's also, I mean, if we use array.length is no problem, but if we use a syntax like this, for me, it's just cleaner to understand what this loop is doing. It's printing the whole thing of the array, right? So if I save this and I run, I'll get the exact same output. I could also, let's see if this works, r.forEach, right? And then here we can pass an arrow function, console.log element. Now this is a little bit more advanced syntax, and what I'm doing here is basically, well, let's see if we can understand. Maybe here, let's change this a little bit to make it more clear. Let's pass a function here, and the parameter is going to be an element. And then here we'll say console.log element, right? So here what this is doing is basically saying, okay, for each element of the array, execute some function within or for this element. If I save this, I'm going to get the exact same output, 1a, me, and minus 2. Now, this is just another way of writing a loop like this, but you may find this quite often in some JavaScript code. I just wanted to show you this here. Once we discuss arrays, we'll discuss a lot more methods to manipulate and to iterate over arrays. We also have array.map, which is very nice. So yeah, here is just a syntax introduction. We'll discuss arrays in more detail later on. Let's go back here. We can mark control flow as completed, and we are almost done, at least with this introduction, right? So new exceptions. Let's discuss exceptions in JavaScript, and we already came across an exception. Let's again start with a simple array. It's going to be an empty, let's call it 1 like so, or for the sake of more clarity, just an array with my name, and we will try to console.log array 1.firstname. Right, so say that by some reason I got confused and I thought that this was an array of objects, or actually even better, let's make this an array of objects. First name Lauro, like so. And then by some reason I thought that I would have a second element in this array, but I don't really have a second element. So if I were to save this and run this here with node exceptions, I'm gonna have some weird message printed on the screen. And if I were to add some other command here, console.log, this is a second command. So if I were to add a second command, this is not going to be executed. As you can see, the code is going to be terminated. The program is going to be terminated. The code is executed. The whole thing crashes because we have an error. Now, how do we deal with this error? How do we deal with this exception? That's where exception handling comes in JavaScript. A way for us to deal with exceptions is to surround a certain code block in a try catch statement. Right? So now here we can say try to run this code, and as we will see, this is not going to output anything on the screen, but let's see if we can make this one actually print. So if I save this, at least the code continues to execute. So as you can see, if there is some error that happens here within the try statement, we can still continue the execution of our code. And fine, maybe the code here didn't execute successfully, but at least it didn't break the whole thing, right? We can also use the catch block to output something here. Console.log, an error has occurred. I think that's the right syntax. No? Like this? Yes. If I save this and now I execute the same program, we'll see we have an error has occurred, and we continue the execution of our code. So this is how we will handle errors in JavaScript most of the time. Try and catch. We also have the possibility of adding a finally statement here, and the finally statement will be always executed, right? Console.log, I will always be there. I will always be there. Right? If I save this, I'm going to execute this, an error has occurred, I will always be there, and this is a second, but not a second anymore, that's a third command. Now let's add here another one, the same object, or yeah, just a second object. They are not really the same because remember, objects are by reference. I mean, we will discuss what this exactly means at a later point, but this simply means that for objects, even if they have the same shape, they are going to be different if they are not coming from the same variable. So maybe I can just really give you a very short introduction here. Let's say obj1 is going to be first name Lauro, like so. And we'll say obj2 is going to be first name Lauro. And then we'll say obj3 is going to be equal to obj1, right? So I know it's getting a little bit confusing, but let's do a couple of console.log statements. obj1 equal obj2, this is going to be false. obj1 equal obj3, this is going to be true. And obj2 equals to obj3, this is going to be false. Right? So this is going to be false, this will be true, and this will be false. I'll save this, let's execute, and exactly as we expect, false, true, false. We will discuss why this is the case at a later point, but I can just tell you very briefly, when we create an object in JavaScript, we are storing, as I said, the reference or the identity of that object in the variable. When we create another object, this object has another reference. It has another identity. Even if the shape is the same, this reference is different than this reference, right? And that's why this is outputting false. Now, if I take the reference from object 1 and I assign this reference to another variable, then the reference is really the same, right? So that's why this is printing true. But nonetheless, or in any case, this is not really about objects and primitives here. We'll discuss this in a later point. Here is about error handling, right? So if I save this now, because I have a second object here, we will see the first name printed, and then I will always be there, and this is a third command. So if I execute this, there you go, Lauro, I will always be there, and this is a third command. Pretty cool, right? So this completes the exceptions part, and now semicolons. And semicolons is more of a, let's say, philosophical discussion, if you want to call it like this, and it is about whether we should use semicolons or not. I'll use the same file here and just remove the whole semicolon thing. I save this and I execute. in the console, and it works just fine. It's no problem, right? So you can write the code without semicolons or with semicolons. Originally, not putting the semicolons was a problem, but most of the IDEs, I think, and most of the actually nowadays the compiler is smart enough to identify when a certain statement ends. Nonetheless, I really prefer to use the semicolons. I think they make the code much cleaner to understand because we can actually visualize when a certain statement ends, right? It may be the case that we have a longer statement and a couple of parentheses, and it's not easy to see where it ends. Now, we could break this down into maybe different variables to assign intermediate values, but from my perspective, I think it's very little effort to add the semicolon here, and I think it makes the code much easier to read. So this is just a brief discussion that I wanted to mention about semicolons. And from my perspective, I will always try to write them. It's a choice you can make, but I would recommend, yeah, why not? Why not just write the semicolons in your code? It's gonna make it easier to understand. Okay, we have completed all the major syntax elements of JavaScript. And that's pretty cool because I hope that by now you have a good understanding of how the language looks like. As I already said in the course overview, when I go through all the topics, many of these things will be discussed in much more detail later on. So you know how to use them, or at least, no, that's wrong. That's the wrong part, right? You know how they look like, but maybe you don't know how to use them to the best extent, and that's what we are going to discuss later on. It's kind of, you know, when you learn a couple of words, it doesn't mean you have learned the language, right? You try to learn a couple of English words. It doesn't mean that because you know the words, you can go out on the street and start speaking English at a fluent level with everyone, right? So knowing the basic words doesn't make you fluent in the language, and it's the same with programming. Learning the basic constructs, learning the syntax doesn't make you fluent in a certain programming language. So we need to discuss how the syntax is actually used and how we can best, or what are the best practices for the language that we are programming in. So what are the best practices for JavaScript? As I said, this is an overview, but at least now you have a general understanding of how the language looks like, and we can dive into more detailed explanations for each of the topics we discussed today. That's what we're gonna do over the next video, so if you don't wanna miss anything, make sure to subscribe to the channel and you'll get a notification once the videos are published. I'll see you in the next videos. Bye bye!